Okay. So next, coming to cryptography. Cryptography is one of the security tool which is used to ensure secure communication. So basically, cryptography, what it does in the sense, it encrypts the data before sending, and the encrypted data will be sent, and the receiver can only the receiver should decrypt the data. Only after decrypting the data, the receiver can understand what is being sent. Okay. So, so there are two processes involved here. One is called as encryption. The other one is called as decryption. So, if there is some message is to be sent, then the sender the sender what he will do in the sense, the sender will encrypt the message, which we can call it as simply E of C. E of C, E of Y or E of M. Okay, E of M is called as encryption. Once you encrypt the message, this is message, M is a message, S is the sender. Sender will encrypt the message E of M. Once you encrypt the message, what you get is called a ciphertext. Let us call it as C. Ciphertext means it is it is not the text which does not make any sense. The message will make sense, but the ciphertext will not make any sense. By reading the ciphertext, nobody can understand any information from that. Nobody can get any meaningful content from the ciphertext. Okay. After converting into the ciphertext, the sender will send the data to the receiver. Sender will send the ciphertext to the receiver. So receiver gets the ciphertext. After getting the ciphertext, receiver will perform decryption. So let us represent decryption with D. So receiver performs decryption on the ciphertext. As a result of decryption, the receiver will get the original message M. Okay, so this technique is called as so this technique is called as cryptography. So receiver sender will encrypt and the receiver will decrypt. How it is done? So there are two types of encryption. There are two types of cryptographic techniques available. One is called as symmetric key cryptography. The other one is called as asymmetric cryptography. Okay. Symmetric cryptography means what? In the sense, the sender and the receiver, they will both use a same key. For encryption and decryption, a key is required. Okay, key is nothing but a sequence of characters or a sequence of characters or numbers or a combination of both. Okay, that is a key. So the sender and the receiver will use the same key. So that is called as, so let me call it as KS. S stands for symmetric key. So the key used by the sender is also the same and the key used by the receiver is also the same. So sender when you want to send a message M, this is yes, right? So like this is yes, okay. So sender when you want to send a message M, what the sender will do in the sense, sender will encrypt the message using the key KS. Okay, whenever encryption is done, a key is required. Without key, you cannot encrypt. In the previous slide, I have said just you can encrypt because there we have not discussed the concept of key, but with key only encryption happens. So sender will encrypt the message with the key KS. The message is M. As a result, what the sender will get is the ciphertext. Now the ciphertext, the sender will send the ciphertext to the receiver. The receiver will decrypt the ciphertext using the same key KS because both the sender and the receiver will use the same key. That is called as symmetric key cryptography. So receiver will decrypt the ciphertext using the same key. After decrypting, the receiver will get the original message, which is M. Okay. So during the transmission period, during the communication channel, while it is getting transmitted to the network, even if an attacker gets the data, he will get only the ciphertext. That is C only he will get. And with that, he cannot do anything because C is not readable. And, and the attacker cannot decrypt it. Because for decrypting, two things he should know. One is he should know the decrypting algorithm. Another thing he should know the key. Okay. So, so the encryption will be done through encryption algorithm. Decryption will be done through decryption algorithm. Basically, decryption is a reverse of the encryption. So as the attacker will not be knowing the key and the decryption algorithm, so the attacker cannot get the what you call message. So this is how this particular symmetric key algorithm works, right? So, so there are different types of symmetric key algorithm available. So there is an algorithm called DES, uh, which is uh, which is one of the mm, uh, most older symmetric key technique. Okay, and this symmetric key technique can be applied at different levels. It is not that one level. Say there is an algorithm called triple DES. There is an algorithm called triple DES. It applies symmetric key technique for 3 times using 2 or 3 keys. Using 2 or 3 keys. See what it is doing here. The sender, what he is doing is to create the ciphertext C. The sender is first encrypting the message using the key K1. Okay, the sender is first encrypting the message using the key K1, and then he is decrypting the message using the key K2. See, if the message is encrypted using K1, then you have to decrypt using the key K1, then only you will get the message. Otherwise, you will not get the message. So this is also, even though this is decryption, this is also equivalent to encryption, because originally the message is encrypted using the key K1. Again, you are decrypting with the message using the key K2, means this is also one form of encryption. This is not decryption because another key is used. Again, that is encrypted using the key K3. Okay. As a result, what you get is the ciphertext, and that is sent to the receiver. Now the receiver, to get the original message, what the receiver should do? First, so there are 3 levels of decryption, 3 levels of encryption. So first, the receiver should decrypt using the key K3. Okay, using the key K3, because the outer level is what? Encrypted with K3. So first decrypt with K3, then it is decrypted with K2. Now you encrypt with, the receiver should now encrypt with K2. The receiver should now encrypt with K2. This is second level. And in the third level, it is encrypted with K1. So the receiver should decrypt with K1. Okay. So all so of C. So the receiver, so all these things should be done. Okay, right? So when the receiver performs all these things, when the receiver performs all these uh, sorry, I think I'm representing in the wrong way. Yes. So see this at the top level, it is encrypted with K3. So that will go in the least level. Okay. So when you decrypt with K3, when you decrypt with K3, so first you should decrypt with K3. Okay. Then once you decrypt with K3, what you will get is you will get this part of the message. You will get this part of the message. Okay. So now you got this part of the message that you encrypt with K2. That you encrypt with K2. Okay. That you encrypt with K2. Okay. And at the, so once you encrypt with K2, you will get this part of the message. Okay. You will get this part of the message. Okay. That you decrypt with K1. That you decrypt with uh, d of K1. Okay, d of K1. So then you will get the original message. So this is what the receiver should do. Okay, like that, different levels of encryption can be used, and the keys will be very long. For example, there is an algorithm called AES, Advanced Encryption Standard, where there are keys of this much size were used, 128, 192, or 256 bits. Okay, so this is how the symmetric key algorithm works. Basically, it uses one same key for encryption and decryption, right? So this diagram just explains that. So the original message that you want to encrypt is called as plain text. Okay, the message is otherwise called as plain text. The message is encrypted using an encryption algorithm and using a key K. There is an encryption algorithm which is encrypted using the key K. As a result, what you get is called a ciphertext. What you get is called a ciphertext. Now the ciphertext will be sent to the receiver. Okay, receiver will decrypt the ciphertext using the decryption algorithm using the same key K, and as a result he will get the plain text and he can read it. Now even if the attacker is in between, attacker can get only the ciphertext. So attacker cannot understand anything from the ciphertext. Attacker cannot understand anything from the ciphertext. So this is the channel network. So this network channel is insecure. That is, anybody can read something. Somebody can tap and wire and they can read. But now, even though attacker reads, the attacker cannot make anything out of that. Okay. As sender and the receiver are using the same key, one of them should generate the key, and it will be shared between two. Okay. Or in some cases, either the sender can create the key and give to the receiver, or the receiver can give the key, create the key and send to the receiver, or in some cases there will be a central party which will create the key and they will send to both the sender and the receiver. The central party is something is called as a trusted arbiter. Okay. So this type of algorithm is called as symmetric key algorithm. The next type of algorithm is called as asymmetric algorithm. In an asymmetric algorithm, there will be two keys. Every user will have two keys. One is called as public key, the other one is called as a private key. Okay. Every user will have two keys. One is the public key, the other one is a private key. So uh, let us assume there are two users, say Alice and Bob. Okay. So Alice will have his own public key and private key. Okay. Say Ali's public key is E comma N. Okay. Say Bob's public key, say Ali's public key is E comma N, Ali's private key is D comma N. Say Bob's public key is something else, C comma N and F comma N. Okay. Right. So this is Ali's public key E comma N, and this is Ali's private key D comma N. This is Bob's public key C comma N. This is Bob's private key F comma N. Okay. Like that, there can be any number of users. All users will have their own public key and their own private key. Now what happens in the sense, everybody's public key will be known to everyone. Everybody's public key will be known to everyone. So Alice will know Bob's public key, and Bob also will know Ali's public key. Okay. So if there is another user C, he is having some public key D comma N and some private key G comma N, then C's public key will be also known to everybody. Okay. So public key is public. Everybody's public key is known to everybody, but nobody will know their private key. A's private key will be known only to A. B's private key will be known only to B. C's private key will be known only to C. Okay. Now, what should they do with the public and the private key, right? Say for example, if if allies want to send a data to Bob, if allies want to send some information to Bob, okay, and allies want to ensure confidentiality, and allies want to ensure confidentiality. That is, confidentiality means only Bob can read the data. Nobody should be able to read the data. That is called as confidential. Only Bob should be able to read the data. Nobody should read the data. That is called as confidentiality. Then what allies will do in the sense, allies will encrypt the data using the public key of Bob. Okay. Allies will encrypt the data using the public key of Bob. Say I'm calling the public key as U. U represents public key and B represents Bob's public key and the message. So the message is encrypted using whose public key? Bob's public key. As the result, whatever the ciphertext is generated, that is sent to Bob. Okay. If some message is encrypted using someone's public key, then that can be decrypted only by using their private key. Okay. If a message is encrypted by using someone's public key, then it can be decrypted only with their private key. So this message is encrypted using Bob's public key, so it can be decrypted only by using Bob's private key. And Bob's private key is known only to Bob. C, D, E, and other users, they don't know Bob's private key. They know the public key. Okay. So only Bob can decrypt it. Even if others receive this data, they cannot decrypt it. Okay. If a message is encrypted using someone's public key, then it can be decrypted only by using their private key. So now Bob will decrypt it using his private key. So let me call it as private key as R. So it will be decrypted by using the private key of Bob, and now he will get the message. Okay, this is to ensure confidentiality. But if A want to ensure authentication, he don't want confidentiality. Authentication means to ensure that the data is coming from the correct person. Authentication means, please try to understand, authentication means that to ensure that the data is coming from the correct person. So A is sending the data to B, but how B will ensure that this is coming only from A? Or, or how B will know that there is no attacker in between and that attacker is not sending that? How can we ensure that? For that, if authentication is required, then allies, what allies will do in the sense, allies will encrypt the data using his private key. Okay, what that is using the private key of A. A's with A's private key, allies will encrypt the data, and then allies will send the data to Bob. Okay, yeah, allies will encrypt the data using A's private key. As a result, whatever the ciphertext is created, that is sent to Bob. Now this message is encrypted using allies private key, so it can be decrypted only by using allies public key. Okay, fine. This is here allies want only authentication. He don't want confidential. That is, anybody else can also read, not a issue. But how would you ensure that it is only coming from allies? Because it can be decrypted only by using allies public key. If you want to decrypt it, you have to use allies public key. That is, you have to use KUB. U represents public, sorry, KUA. U represents public key, A represents allies. So as this message is decryptable only by using allies public key, this message is only coming from allies. Okay, so this is how this public key cryptography works. So to briefly to say, in a public key cryptography, there will every user will have two keys, a private key and a public key. And the public key of all users are known to everyone. When the user want to ensure confidentiality, when the sender wants to ensure confidentiality, the sender will encrypt the data using the receiver's public key, and then he will send the data. Now the data can be decrypted only by using the receiver's private key. As nobody else knows the receiver's private key, only the intended receiver can decrypt it. If the sender wants to ensure authentication, then the sender will encrypt the data with his private key, and then he will send the data. Now this data can be decrypted only with the sender's public key. So this will ensure authentication. So this is how encryption and decryption is achieved. Okay. So there is an example. I don't want to discuss that because it will be lengthy. And then authentication is also done by using something called as hash function. So which is also otherwise called as message digest. So like how we have discussed some hashing techniques. So using a hash function also authentication can be achieved. Fine. Let us stop this topic here. Thank you.